Okay. So we're looking at the wave model of light. And I did go into a bunch of this the last lecture I was talking about. So it's going to be a little bit of repetitiveness here, but bear with me. So wave model of light. So light is a form of energy that travels in waves. Our eyes and brain can detect, interpret, and separate visible light into all the colors of the rainbow based on the properties of the light waves. So think of water waves, and I did mention this before. A water wave is produced when energy passes through the water, right? So when you cannonball into a pool that is calm, you're putting your energy into that water, which is how caused those waves to ripple, okay? So a water wave is produced when energy passes through the water from one point to another, causing the water to rise and fall. So this basically means that the water particles do not move forward as the energy passed. It will only move up and down. Only the energy is moved forward. Okay, so it's that energy. So there's the little picture there. So you have the duck that's moving up and down with the wave as the energy is moving forward. And then the duck moves up and down with each wave. Okay, so there's properties of waves. And I did go into all of this the last one, and I didn't mean to go too much into it, but it's fine. Now you actually maybe remember the words. So to understand how waves transfer energy, there are some important terms you'll need to know. So the crest is the highest point of the wave. So we got a little chart down here, which is very nice to see. So the crest is the highest point in a wave, and the trough is the lowest. And see then that dotted line I said is neutral position, also known as the rest position. Okay, so the level of water when there are no waves. So if you, before you jumped in the pool, if it was calm, the water would be sitting right here on that rest position. But then you jumped in the water, bringing your energy with it, and now you're causing those waves to go up into a crest and down into a trough. Okay, so there are three important properties of waves. So we have our light wavelength. So it's the same point on either side, okay, is a full wavelength. So it has to have a full crest and a full trough, okay? That's one full wavelength, okay? The distance from one place in a wave to the next, similar place in that wave, is referred to as, it's your wavelength, but it's represented by a lambda, and you can see that there, okay? It's kind of not fully, it's almost like a TP type symbol. Light waves are measured in nanometers. And then how small is a nanometer? I want you to look into that, and we're going to talk about that first meeting tomorrow morning. Amplitude, the height of the wave. Okay, so this is where our amplitude is, from that rest position to the top of the crest, or from the rest position to the bottom, which is the trough. Because again, just so you know, that height is the same on a wavelength. So the height to the crest or the height to the trough, those are the same on one complete wavelength, okay? So the taller waves possess more energy. So remember that, okay? So the taller the waves, the more energy there is, okay? Frequency is the rate of repetition of the wave. So it is measured in hertz, okay? And then you have your representation is represented by the capital H and the Z, okay? The higher the frequency, the more energy that the waves pass along, okay? So that frequency I mentioned before is how many waves are going to pass through in 10 seconds in that one spot. And then compared to if you put more energy and you waved the slinky more, there's going to be more waves that pass along that spot, right? So it's the more energy that's moving along. Okay, so that's the extent with the wavelength, okay? You will need to be able to label it, okay? Again, you're not going to be labeling it, but, on a quiz or a test, you will have to do a matching of which one is which, okay? Now, there is equations that go along with this, but you won't see those until grade 11 physics. Coming down here, so I did mention this in the last one, just to compare the wavelengths here with our visible light spectrum to both frequency and wavelength, okay? So which color has the highest frequency? Which color has the lowest frequency? And I read it different ways, but that's okay. So we talked about it. So frequency, again, the higher the amplitude, the more waves are going through in one section. So our higher frequency would be our violet. Our lower frequency would be our red. But then reverse that. What has the longer wavelength? What has the shorter? Well, red has the longer wavelength. Look at our wavelength up here. And violet has the shorter. Look at our wavelength up here. Remember, if you're going from one top to the other top, whereas one top all the way to the other top. So red has that bigger wavelength. Violet has those smaller wavelengths. But that's because there's more energy going through this than there is going through this one. Okay? So how is light produced? Right? So light is the form of a radiant energy. So hopefully you've gotten that can be detected by the human eye, right? That visible light of the electromagnetic spectrum, that is the form of energy that we can see. So it's that whole is the electromagnetic spectrum. That is all energy, right? That is all energy in there. Visible light is the only form of energy we can see. There's all those are energies. So light is energy. It's all energy. But the visible light is the only one we can see. So I want you to take that into, just wrap your head around that. Electromagnetic spectrum is the wide variety of energies there is out there. Visible light is the one that we can see, okay? So it travels or radiates in all directions from the source, okay? We're going to look at more examples of that later. So objects that produce light are called luminous, all right? So what is an object that produces light itself? Oh, well, let's think the sun. The sun is luminous. These can be both natural and artificial, okay? A luminous object gives off light as a result of a physical or a chemical change. Remember, one of those things like, what is an example that chemical change has taken place? Well, light was produced, right? That was something you learned in grade 9. So during the change, some other form of energy, such as a chemical or heat energy, is converted to light. Most objects do not produce their own light. These are called non-luminous sources of light. Light reflects off of these objects. An example of that, and I'll tell you right now, is the moon. Okay? The moon, it has a reflective surface, right? You learned this in grade 9, actually. Remember in astronomy, the moon is reflecting the sun, and it's always reflecting like the full sun. It's like there's always going to be a full moon, but depending on where we are, we can only see certain parts of it. Sometimes we can see all of it, which is on the full moon. Sometimes we can see none of it, which is when it's a new moon. But the moon is a reflective surface, okay? So that would be our non-luminous source of light, okay? All right, so going down, so these are things that I would like you to do. There is a chart here. You can either copy this or you can print it off. If you're able to print, then that's great. You can print. But this is, you're going to have to fill this one out, okay? So using the textbook, all right? And I'm showing here. So producing visible light, pages 392 to 398. Complete sources of light worksheet. You don't have to do the questions. I just want you to be able to fill out this chart of the definition of what the different types of lights are and an example of each. And I just gave you a couple. Now, the worksheet is on, hang on, I'm going to just pull this up for you right now. The worksheet is here. Oh, no, wait, it's here. Sources of light worksheet. And I'm just showing you here. I wanted to show you this one because it has a lot of space, but because I gave you the first one. It is not in your textbook, okay? So fusion reactions, that is not in your textbook, but this is the source of light that comes from the sun. So this is when fusion reactions warm and excite a layer of gas, which releases energy in the form of light. This is what's happening with the sun, okay? So I want to give you that one because you don't have, that one's not in the textbook, but it says at the top of your textbook, pages 392 to 398. That is where you'll find it. I'm going to just pull this textbook source up. So this is what it looks like, okay? This is the textbook online. Not super easy to navigate, okay? I had struggled trying to find things on this, but I'm just going to take you down here, okay? We have here where it says, so I said 392. So there is some, talk about the bioluminescence there, and then the sources of light emissions. And And then down here, it has each of them individually. So you'll just have to click on each of them, get your definition, get your example, but look it over. So I'm going to do the incandescent light. But it just shows brief. You don't have to read through everything, but just enough to get, the basics of how they work. So this is how light bulbs work. Okay. And then you can go and fluorescent light, and you can look how fluorescent lamps work. And there's little videos. You don't have to watch the videos if you don't want to. But if videos help you for understanding, then it might not be a bad idea. So that's for this one, for this exact activity. Just go through and click them all. This is not a great source textbook, the online one. I don't find it super easy to work. And as we get more into the physics part, as in the math part, I'm not going to use the textbook very often. Okay. When we're in class, I don't tend to use the textbook very often. I like to give you my own questions and you work through them and we take them up. And that's what we'll do when we get into more of the physics questions. But for this stuff right now, because it's more just definitions, we'll use it. But yeah, don't get too comfortable with using this textbook. This one's not, the online one is not easy to navigate. It's kind of frustrating. But I just want to show you that's where you get to fill in this chart. Okay. And I just totally lost it. Where is it? It was 392 or something. There you go. 394. Soon you got all the different ones there. Okay. So that's what you're going to go and work on and fill that chart out. Now, okay. And then we will continue with our next lesson after.